This is Vincent. Is it Romanin? Is that how it's pronounced?
You're really close to the original Italian pronunciation. Most of my American family pronounces it Romanin, but you were
Romanin.
technically closer to correct.
Closer to the empire.
Yes.
But now I used to work a lot with a guy named Paul Romano,
Oh yeah.
and not Romano. But anyway, um, and he's the founder and CTO of Gradient Comfort, which is an innovative window heat pump solution for HVAC upgrades and specifically focused right now in multifamily buildings. So I think it's an interesting for this group to hear about and also for us to archive it on the Connecticut Green Bank. So with that, I'm going to, for the audience, if you can mute yourselves, and then, but if you have questions during, just raise your hand in the participant list or put something in the chat. And Vincent said he'd be fine with us interrupting to ask specific questions about specific issues that he's talking about at the time. So Vincent, have at it.
Great. Thank you, Dean. Thank you all for having me. Excited to give this quick intro to what we do. As Dean said, please feel free to ask questions in the middle. We're happy to make this a conversation. I'm also here with Sam Lamos, who is our policy lead and works a lot with customers up and down the Northeastern corridor. And so we're excited to chat with you all here today. So I'm going to go over a quick intro of us, the company, of window heat pumps as a category, some of the features, specifications, applications that they fit into and why. And then we'll end with a case study where we talk about some of the installs that we've done and how it's gone. So a quick overview of us as a company. We have systems all over the country right now. We believe in about 36 states. We have partnerships with a lot of large organizations like NYSERDA, NYCHA, and headquarters in San Francisco, but a lot of our customers are in the Northeast corridor, New York City, Boston, and from my understanding, a lot of the types of customers we're looking for also exist in Connecticut. So we're excited to have a focus on Connecticut. As I mentioned, I'll go quickly over the market for window heat pumps, how they fit into the landscape of competing technologies, and why we see our customers choosing window heat pumps over those other technologies. I'll then go through specs of our product, what it does, where it fits, capabilities, etc. And then lastly, we'll end with a quick case study. So quick intro. I am the founder of the company, so you'll please excuse me if I nerd out a bit and kind of go into the why a little bit here, but I think it sets the stage for why the product does what it does and where it fits. Our specific focus right now is pre-1980s construction multifamily. Obviously, if anyone is interested in the product, we will pick up the phone, but I think we have a really unique fit here. And one of the reasons for this is that if you look in the data, heat pumps have a much lower penetration once you get into older construction. And the reason for that is probably obvious to a lot of you here. When you look at these older, especially multifamily buildings, the cost of retrofits is often very high due to the permitting, skilled labor. Often there's mitigations needed on the building. Contractors are expensive. Electrical upgrades are often needed. And it's all of the on-site construction, on-site modifications to the building, on-site permitting that can tend to drive the timelines and cost for these projects up really high. And despite that, these buildings often have some of the worst HVAC systems. Most need repair, that most frequently fail, or frankly, that need upgraded for resilience and public health reasons. Buildings like this often house populations that are vulnerable to heat waves, or for whom it's very important to have reliable heating during the winter. And so there's a lot of reasons that these buildings are looking for these upgrades despite the barriers that they see here. So I recognized this when we founded the company, and I really thought, what do we need the future of heating and cooling to be, not just for this market, but really broadly. First, we want it to be better for the climate. We know that buildings are a huge source of greenhouse gas emissions. And what does that mean? How do you get to zero emission building heating and cooling? Well, you need a couple things. First of all, you need systems that perform well, of course. That's probably obvious. Often also on the efficiency point, systems we've seen don't always perform in the field the way they perform in the lab. So for us, efficiency doesn't just mean a high efficiency system. It means something that you can reliably expect it to perform after installation the way that it is said to perform on paper. We also want these systems to be electric for decarbonization reasons and variable speed. Variable speed dramatically increases the performance of these systems, and so that was key for us. Better refrigerant management is very important. Refrigerant management, if refrigerants are improperly managed, a heat pump could be as bad for the climate as a fossil fuel heating system. And of course, if we're going to change our infrastructure, we don't want to replace one problem with another. And so that was really the goal in terms of better for the climate. Of course, customers don't care about that. That is what we care about as a company. It is not the thing that we talk to our customers about. They love that it's better for the climate, but it is not our focus. So what is the problem that we're solving for the users and the customers of the system? First, we want reliable systems. They have to have high uptime and low maintenance cost. They have to be networked. We've found that the ability to see how a system is operating, to understand its health from the cloud, can both let us ensure that the product is working as intended, let us design better products faster, and it greatly lowers the cost of maintenance because you can be predictive with maintenance instead of doing emergency calls. And so we wanted these systems to be networked from the start. And we also wanted them to focus not just on the temperature requirements of the building, but on a broader view of what comfort and health means for these residents. And that means things like ventilation, air quality, humidity control, and then more emotional things like the noise and aesthetics of the building. You know, if we change from radiators, which you commonly see in multifamily buildings, to something that's actually worse, there's going to be that is going to be a big inhibitor to scale. And so when building owners are making decisions in their infrastructure, they want to know that their tenants are going to be happy. Lastly, cost-effective and scalable. And as I mentioned before, the main thing that makes this cost-effective and scalable is something that is low cost to install. We also want to be able to quickly train workers. We found many customers in the space have challenges with finding work source that is skilled and trained to install advanced heating and cooling systems. We wanted this from the start to be modular, and the reason for that is it is more mass producible and therefore cost effective. It also minimizes the on-site configuration, which means faster deployment, and it means higher reliability. And lastly, we wanted to look at a system that was as broadly compatible as possible. And so we did a lot of work to make sure our system was installable in many different configurations. And so, and data driven. I talked briefly before about networked for maintenance and for verifying performance. And so this was kind of the approach that led to designing our system. This is, of course, our second generation system. It is a cold climate capable heat pump. It does both heating and cooling, and so it can operate all year. We have several installs in the Northeast in places like New York City and Boston, where this is the only source of heating and cooling in the building. And it can do that because it operates down to negative 13 F, and it has fairly high capacity and efficiency at those low temperatures. It does that out of a standard 120 volt outlet, and so it plugs into the outlet that is already in your wall. This is really important for lowering the cost of install and improving the speed of install. We also have the ability to add air filtration to it. We have a powerful enough fan to do MERV 13 filtration, which makes it better for residents' health and comfort. The install into the window is done without any drilling. There's not even as much as a screw in the wall. It can be done by non-professionals. The training to install this takes just a couple hours. Basically, anyone who can lift a box and who can turn a screwdriver can do it. And it removes the single point of failure of heating and cooling in buildings. And so this is a very distributed, robust solution. I'll do a quick video that shows what the install process looks like. The system comes in one piece, fully packaged, which means there's no HVAC technician needed to run refrigerant lines. We have an adjustable bracket that fits a wide range of window dimensions that goes over the windowsill. The system that has a rotating bridge, so from the inside of the apartment, two folks can rotate it into this configuration, lift it up, and set it on the bracket. The bracket has a track to ensure that it can't fall or you can't drop it. And then there's an air spring, so it lowers into place easily. You then seal the window with the included sealing kit. You then plug it in and you're up and running. And so as an example of this, we did an install recently. Actually, I believe Eversource was there at this install, along with another utility, where we knocked on the resident's door. We installed 2 heat pumps and then we left all within 45 minutes. And so really minimally disruptive to the resident, and really quick to install. That was probably our record for install. Most often it's around an hour or less per gradient unit. But as we kind of streamline the training and install instructions, we're getting slightly faster. So the way that this ends up competing against other systems is that similar to a window AC, we don't have refrigerant handling. We have plug-in installation, and it doesn't require any modifications to the building or permits, and so it's very fast. However, it has the cold climate heating capability and the zonal control that you'd expect from a professional system like a mini split. A bit more detail on the product itself. Today, as I mentioned, we are very focused on older construction multifamily buildings. Often these buildings have boilers and steam radiators, most often single pipe steam, but we're working on a lot of different types of projects. Some of our customers have all electric heating, which we're replacing. Most of these buildings, because of their age and because they have a steam radiator, that also means they have no cooling. And so we are either replacing a window AC with a more robust, efficient cooling solution, or we're adding cooling for the first time. We are exploring and are interested in conversations with single-family homes, ADUs. It's not our focus today, but in the near future we will. We do think that there's going to be eventually interest in renters who, instead of selling to the building owner, the renter would have the ability to put this into their home. And we are looking at expanding into other window types, but today we don't. We only focus on sash windows, up and down opening sash windows. And then eventually we will look at integrating other features like ventilation and making the system smaller and more integrated with the building design as we grow into new construction. But that is not our focus today. Today we're exclusively multifamily. Another thing that makes this incredibly modular and quick to install, if we have the bracket over the window solved and we have the electrical solved with an outlet, the next thing you have to worry about is condensate. Of course, if you are an AC, you can drip condensate in summer and it's a bit of an annoyance, but people can live with it. That is not true in heating mode. When this is operating as a heat pump in cold weather, you have to defrost the outdoor heat exchanger. And of course, if you drip that melted ice water or that melted ice, you will cause an icicle or ice puddle or something that could be a health hazard. And so what we do is we atomize the condensate, both the condensate that is melted off the heat exchanger in heat pump mode in the winter and the condensate that's produced in the summer are atomized into a fine mist or a fog. There's 3 independent nozzles in the outdoor unit that can do this. It is an ultrasonic activation, and so it's very resistant to clogging. And we, basically turn it into mist. This is done out of the box. It means that you don't need to install any drain lines in the system. There is a port in the bottom of the system to install a drain line. And so if a customer would like to drain it with a traditional drain, that is totally fine with us. But most of our customers just use the nozzle, and it prevents any ice buildup on the outside of the system. Airflow and filtration, also fairly important. First of all, we have a very high airflow fan. It's about 400 CFM. This is somewhere around 50% more airflow for BTU than you'd expect from most systems. That is important for efficiency. It's important for room air mixing and comfort, but it also lets us have the ability to add a MERV 13 air filter because our fan can handle that pressure drop. And so the unit ships with a pretty standard MERV 2 filter that is washable. But if you would like to add MERV 13, there's a disposable option that will control particulates, pollen, allergens, disease transmission, etc. Um, the inlet also has dual vents. There's a vent here at the top that you can see. There's also a vent at the bottom that's kind of behind the grate here. And so the ability to exhaust out of both the top and bottom of the system helps with room mixing. A lot of people in winter want to close the top vent and only use the bottom because they want the floor vent in heating mode. It, warms the floor, warms their feet, and leads to better air circulation because that air then rises. And so we have the fairly powerful fan and high airflow really helps a lot with comfort. As I mentioned, we have a pretty streamlined installation process. It is adaptable out of the box to a wide variety of windows that we've seen. Anecdotally, it's somewhere around 80% of sash windows we're compatible with. Some windows are too narrow. Sometimes the sill is too deep. Those are probably the most common incompatibilities, but even those are pretty infrequent. So about 80% of sash windows are compatible with this install. We also have done a lot of work to make sure that the seal after you put it in is very insulating, that it prevents air leakage through the window and that it prevents heat conduction loss through the window. We've tested this in the field and we've seen pretty good insulation with the outside air. The net loss in even the worst case amounts to just 2 or 3% of the total system capacity and efficiency. And so our window sealing has been pretty secure. Lastly, we do have the ability to have a window lock so that people on the first floor can be sure that no one from the outside is able to open their window. These are pretty standard off-the-shelf locks. You can buy them at Home Depot today. And so from a security standpoint, it's better than a window AC. You could obviously push a window AC in and have a hole big enough to crawl through. You couldn't do that with ours. And then the bracket is fairly robust and strong too. We have unfortunately had 3 individuals who tried to steal a system from a first floor apartment from the outside. They were unsuccessful and they didn't damage the system. The system was in fine working condition afterward. So we unfortunately know from experience that the outside part of the system can support the weight of at least 2 individuals.
So are you putting like a pin or something through the window to keep the window in place?
So do you mean for a from a security perspective to lock it?
Yeah, right, yeah.
The way it usually works, let me find a picture of a window here. So the way it usually works is, can you see my mouse?
Yes.
There would be a little lock that goes right above the lower sash of the window. Sometimes these stick onto the glass of the upper sash and have a little latch that flips down and like lands on top of the lower sash of the window. Sometimes these are screwed into the frame on the side of the window. One of our customers just took an angle bracket and screwed it into both the wall on the side of the window and then the top of the lower sash of the window. You could cut a bar to the appropriate height of the gap between the lower sash and the top of the window frame and put it in there. And these are what's most common. We don't provide anything out of the box because we find, first of all, this is only something that first floor customers seem to want. And second of all, a lot of these solutions are all available at Home Depot. They're fairly standard and so pretty easy to source to lock the window.
Thank you.
A lot of the issues that I mentioned earlier, we found a lot of customers will install heat pumps and they will not see the performance that they expect. We really wanted to figure out how to make this predictable, how to make sure we could help customers understand what their energy use is going to be and then verify that is in fact the case. And so the fact that there's, no commissioning required, you don't have to do any duct balancing, there's no refrigerant charging required, really does mean that the system should work out of the box the way every other system works. And so that's super important to us. At end of life, all of the components inside of it are standard compressors, refrigerant, heat exchangers that you'd find in any refrigerator, AC, or heat pump. And so it fits really well into existing recycling and disposal systems. And we also fit into a similar code as window ACs. We We have an even more secure bracket than window ACs. We are electrically a similar device. And so that means no permits required, and it makes the commissioning really simple. And so we like this architecture because it fits into a lot of paradigms for systems that already exist. And so it's easy for building owners and code officials to understand. One thing that's a little bit less easy, we worked with the DOE to define the performance metrics for this category of systems. We don't quite fit into window AC test procedures because they don't exist for heating. We do fit into the way that they test cooling, but we don't fit into the exact test procedures for a mini split. And so we worked with DOE to define the HERE rating. We asked them to sync the rating to HSPF2 so that you could have an apples to apples comparison. Unfortunately, that's not the case. We also kind of advocated for our cooling efficiency rating to be matched to what mini splits are rated to, which is CER2. That's CER with an S. Unfortunately, that's not the way it landed, and we are now rated to CER with a C, CEER, which is hard to pronounce differently than CER with an S. And so our performance is rated to CER and to HERE. Any tables we've translated it to how roughly we would expect it to land in HSPF2 and CR2 in case you want to compare it to a mini split. Do you have anything to add to that, Sam?
Yeah, just one note. So obviously we've created our own internal crosswalks for SEER and HERE. But we've been working with CEE to have them develop a crosswalk. So it's coming from a third party independent, organization that can provide a little bit more validity to the crosswalks that we're demonstrating here.
Quickly on performance, we have a full spec sheet that we're happy to send to anyone who's interested. But this shows for given outdoor temperatures what our performance is. Our 9,000 BTU per hour rating is at 17F, which we find most folks who are speccing this, as a heating system in places like New York City, Boston, or presumably Connecticut, look at that 17F design point as a key capacity point. And so 9,000 BTU per hour and 2.37 COP, which we think is fairly high, and lets us fit into existing electrical systems. And then all the way down to negative 13F, we are still at 7,000 BTU per hour, which we find for most multifamily buildings especially is more than enough capacity. We've seen no issues with the coldest day in winter so far. In heating performance, in terms of the range of capacities, we have those listed here. As you'd expect, we can go up to a much higher maximum capacity at the warmer temperatures. We can list COPs, consumed power, etc., if anyone needs to understand if their building's electrical system can handle it, and if anyone wants to estimate what the energy cost will be for this. Mike asked if the same data is included in the NEEP product website. Sam, do you know the answer to that?
Yeah, so these are all tested to NEEP standards. However, we are still working with NEEP to develop a product specification for window heat pumps. I actually just talked to Dave Liss over at NEEP last couple weeks ago about this. So I think that's in the works for a NEEP spec to be released soon. Did that answer your question, Mike?
Yeah, thanks so much.
And then on window installation, these are the window dimensions that we're compatible with. As I mentioned, the biggest thing probably to focus on here is dimension A in the left-hand image, and dimension C in the left-hand image. A is the sill-to-sill depth, the most furthest protruding indoor sill point to the furthest outdoor sill point. This says 10 to 18 and a quarter with 2 asterisks. Between 18 and 20, we can fit in some windows depending on the overhang, dimension I in the right-hand side. And so basically, if you measure your sill and it's up to 20 inches, call us and we can help see if it fits or not. We've seen some cells that are 22 inches or more. Those are incompatible windows today. We're working longer term on a solution for that, but today we're not compatible. And then lastly, the dimension C, the window width, has to be at least 26 inches. Our product's 25.5 inches wide, and so it needs to be at least that wide. Occasionally, we'll see window sills that are too close to the floor, dimension B on the left-hand side. Usually, there's a way to adjust that with a shim in the windowsill if the customer is interested in that. So sometimes there's some workarounds there. But really, if your windowsill is less than 20 inches, there's a good chance we're compatible. Lastly, Sam did quite a bit of work with the Consortium for Energy Efficiency to make sure that they had a specification for window heat pumps. And they have published their tier 1, tier 2, and advanced tier thresholds for that list. We are in their advanced tier threshold, which we're very proud of. Probably shouldn't be surprising since we pioneered the category that we would be in the advanced tier, but still really happy to be recognized by CEE for this. And this just shows where our specs land relative to that advanced tier. Amperage draw is a common question for customers. We have seen that we're pretty highly compatible with electrical systems. We don't frequently see an issue here. But just this list is typical amperage draws at different outdoor temperatures. They're approximate. They depend on a lot of things, of course. But as you can see, they stay pretty low. So we end up being pretty compatible with the existing electrical systems. And this is really key, of course. If you want to prevent electrical upgrades, this is the main value of efficiency to our customers. It's I think, less energy bills and more, can this keep folks comfortable without having to update the electrical system? Lastly, moving on to a case study. Folks might be aware, but we got a fair bit of press a couple years ago because NYPA, and NYSERDA in New York ran a program called the Clean Heat for All Challenge. The goal was to meet New York City's Local Law 97 targets cost effectively. And they basically came to the same conclusion as us, which is these older multifamily buildings have really, really high costs of retrofits due to mitigation, electrical work, et cetera. And they put specs for this challenge as a 9,000 BTU per hour heat pump that had high COPs at cold temperatures, that could manage meltwater without any additional drains, that didn't require any building modification or HVAC technicians. And Gradient's very proud to have been selected in that challenge for a contract for 10,000 heat pumps with NYCHA. And so we installed the first 36 of those heat pumps pursuant to the 10,000 contract about 18 months ago. And so those units have been running, those 12 homes, that's 3 gradients per home, have been running with only gradients for heating for about 18 months. They removed all radiators, they removed or they shut off steam risers so that there's no heat bleeding into the building. And then they contracted a third party to do a measurement and verification study. The key questions of that were, probably the 4 ones that you would expect. One, can it provide enough heat at the coldest outdoor temperature? 2, what does the install process look like? Are they able to install it as quickly as we say? Can they actually get it into all of these buildings and so it can be located where it needs to be? 3, what does the electrical consumption look like? And then lastly, are residents happy? Do they like it? Are they comfortable? Are they satisfied? We're happy to say we got a very positive answer on all 4 of those questions. This is results from the preliminary M&V study that they published. This is published on Building Energy Exchange's website, so anyone can access it if needed. And key on energy is that it reduced the heating energy by 87%. And so on a pure energy standpoint, like they switched to electricity, but used way, way less electricity than they were previously using in natural gas. That's not too surprising given the overheating and the inefficiency of these steam distribution systems, and given the high COP of our system. But, showing it in the field is much different than showing it on paper. And so we're really, really happy to have this result in the field. If you look at the cost of energy, people commonly refer to the difference in price of electrons versus molecules as the spark spread. Electricity is more expensive per energy than natural gas. And so we also wanted to see, sure, we reduced energy. Did we reduce cost? And the answer to that is also yes. We reduced the cost of heating these homes by about 50%. And not all heat pump applications have shown that. And so we're really happy to have shown reduced OpEx cost substantially and not increased. We had uniform temperature across the apartment, so even the smaller rooms like kitchens and bathrooms that had no gradient were comfortable. We saw minimal electrical impact, about a 30% of load from heat pumps at peak. And so we were a minor part of the electrical load in the building. And then lastly, residents were very, very satisfied. 89% were satisfied. None were dissatisfied. I think it's quite obvious replacing a steam radiator that this is going to be a nicer system. They said that they could breathe easier, that they were more comfortable. They were really happy to be able to set the temperature in winter and not just have to open their window to control temperature. And then, of course, they all had cooling now as well. So they were very satisfied with that. They didn't have to bring their own window AC. They had a quiet year-round cooling solution.
So you just, I think, answered my question. These energy numbers include cooling?
No, these energy numbers are just heating.
Thank you.
They did see, so my anecdotal estimate was about maybe a third of the rooms that we installed in had a window AC. It's very anecdotal, so put huge error bars on that. So there was an increase in the number of rooms that had access to AC after gradient installed. I think we're probably around 35 to 40% more efficient than those window ACs. And then also because we have smart thermostats, because you can just set a temperature, you don't have to turn it on and off, and people generally do turn it off in the rooms that they're not using. NYCHA told us anecdotally that they did not see a huge spike in electricity in summer due to the increased cooling. So they were very happy. They kind of gave us the informal thumbs up and sign off on the amount of electricity used in summer due to cooling. Just a couple pictures of residents. The individuals in the top right and bottom left here are NYCHA residents, and then these are some of our other customers here. But generally, people really like it. Like I said, heat pumps, technologies like this are not going to scale if people aren't excited to get them. We want this to capture people's attention. Like, we know people's homes are very emotional to them, that like the comfort of their home is a very emotional, important part of their home. And so we want people to be excited for this. We don't want that to be the thing that slows us down, and we certainly saw that. We've got a lot of customers who are very happy with the status of their home after this. And so, in summary, we find customers and we get projects because we have lower CapEx to complete the project. We find people whose boilers are failing or who want to electrify to meet local standards, or who just want, their building to be better, lower to operate, more comfortable. And they find us to be about a 50% lower CapEx solution than the other solutions that they see, most often PTACs and VRFs. We also find that we can reduce OpEx by about 50% due to the massive reduction in energy use. And that's usually the start of the conversation for multifamily building owners. I think that the thing that they also like that gives them assurance is that we have the ability to monitor and control these systems from the cloud. It means that we can get ahead of issues and be preventative with maintenance instead of reactionary when systems break in an emergency. And we can help verify that the systems are performing from an energy standpoint the way that they're intended. And then lastly, our customers love that tenants are happier, right? They don't want complaints. They don't want phone calls. They don't want bad press. And if they're market rate, many of our multifamily customers are market rate, they want higher resident retention. There's a lot of data that shows adding cooling can increase rent in these buildings. And so keeping tenants happier also keeps our customers happier. That was all I had for this presentation, but happy to continue answering follow-up questions. And again, I appreciate everyone listening in today, and we'll look forward to hearing any questions you have.
Terrific, Vincent. Thanks. A lot to absorb. A great presentation. Mike, you had a quick question about the data that you showed 2 slides back, I think. Is the same data included on the NEAP product website? the case study results from NYCHA, I guess. Is that
Um,
there or?
The
Oh, I
case
think
study
we,
results from NYCHA are not. Go ahead, Sam.
oh, sorry to interrupt. Dean, I think we answered Mike's question during the presentation about NEEP. The product specification for this product category is not available on NEEP yet, but the test data on our spec sheet is tested to NEEP standards. So basically once they do come out with the specification, we're ready to submit at the moment that they do.
Great, okay. Yeah, and so I had a couple of, and anybody who has questions, feel free to jump in. We're in the Q&A period of the presentation. But I had a couple, so you did 36, and are the 10,000 now on track to get started at NYCHA? Were they all at NYCHA? And now that they've proven out, are you beginning to fulfill on that whole?
The 10,000 will all be at NYCHA. The 36 are part of that 10,000, so we're technically started. We leave it to NYCHA to decide their rollout schedule, and they've told us informally their plans, and we've discussed them so that we're ready to go. But we also like to let them lead the way this project is going. We see this as their project, and we're just a supplier. And they've asked us to make sure that they control the narrative on who's getting these when. Obviously, it's sensitive because a lot of residents want to know when they're getting it or if they're getting it. And also because, they occasionally get, they just want to make sure they control the narrative to their residents. So we have a rollout schedule from them. They are planning to finish this. I think this is publicly stated by 2029. So it'll be a couple years before we get to 10,000. But they've also stated that they're going to continue to electrify their buildings after that. So they've said at least 10,000. They need probably a couple 100,000 of systems like this. And so Gradient certainly hopes to be one of the vendors they use to get to that couple 100,000 heat pumps.
And you were sort of validating concept with the 36 and came
Correct.
back. Yeah, perfect.
Yes.
Great. All right. Like I said, anybody who has other questions, I don't know, Patrick,
Yeah,
go
Dean,
ahead,
this is
Patrick
Paul.
McKenna.
I jumped in on Kathy's link, so
Oh,
she's not in twice. I'm the other one.
okay. Hey, Paul.
I just had I
sorry.
had two questions. First of all, in terms of capacity, do you have different, BTU output options, or is it just a one size? And I'm assuming since this comes right out of the box, the thermostat is directly attached to the unit, even though it's a smart control. You don't have a thermostat set somewhere else in the space.
To your first question, we only have one size. And to your second question, yes, the thermostat is built into the device. You do not need an external thermostat. So on capacity, this is our max and min capacity at each outdoor temperature. Because we're variable speed, we work great at part load. And so we found 9,000 BTU per hour to kind of be the sweet spot for having one size that has the most adaptability to the broadest set of the market. So we do find ourselves to be oversized in some rooms, especially smaller rooms. And, that's generally okay. In the future, we're looking at when it makes sense to release a smaller size, but currently only one size. And then, yes, the thermostat's built in. It has a quite nice interface. You can see it on our website. We also have a demo unit in Brooklyn at the Navy Yard, which is not Connecticut, but also not terribly far from Connecticut. So if anyone wants a demo of a system, we're happy to have you by, or we could bring one to your site in Connecticut if needed.
Great.
There's also
Thank you.
There's also an app on it can connect to your smartphone, or we have an app that you can control it from your phone. So if you have 2 or 3 units in your apartment, you'll see all of your Gradient units connected on one app and control all 3 of them. There's also a remote, so lots of options for how to configure and use the system.
Yeah, great
Patrick,
point. The remote is important for accessibility. We have some customers who are in elderly care facilities where access is important to be able to do from across the room.
Gotcha. Patrick McKenna, you want to introduce yourself and ask your question?
Yeah, Patrick McKenna. I work with a nonprofit, North Hartford Partnership, and they actually looked at a grant to maybe install some of these as a pilot, and some of our buildings haven't received the grant yet, but would love to try them out. I missed the start of the presentation, so you may have covered this. I apologize. But in those NYCHA projects that you did, presumably the heat was provided by the landlord, via steam, and tenants didn't pay separately for utilities. But when you plug these in, they were running off the tenant's meter.
Correct. Yes.
So how did you deal with that? What was landlord paid heat to being tenant paid heat?
This is something that is very top of mind for us that Sam and I have been having quite a lot of discussions about very recently. So it's a timely question. We do have a solution that we're prepared to pilot that is in conjunction with another company who does sub-metering. And so right now, we have not implemented any solution for that. We do report energy use via our cloud, which is not utility grade accuracy, but it should be enough to help set up a solution. And so if you have a project where that is the case and you want to be able to solve that problem, we would love to talk. We believe we have a solution and we'd love to try it out. I'll also note that when that's not the case, when there's no legal issue with moving heating costs from the landlord to the tenant, where it's more of a optics issue, tenant negotiation issue, we found our customers, we try to be flexible for how our customers want to solve that problem. And one example of that is we have a market rate project in Brooklyn at a co-op where the building owner said to their tenants, anyone who gets a gradient, we're just going to credit you the average amount that we pay for boiler upkeep, energy, and maintenance to you if you get the gradient. And so we used to pay X dollars a month to maintain the boiler. We're going to give you that credit and you're going to pay electricity. And because we can be fairly confident that it's going to be lower cost to operate, to heat your home with gradient, the residents that's fine with me. I'm happy to pay this now because I know it's going to be a net money savings.
Right. Thanks. I don't know if you've looked into Connecticut issues, but I know there were some issues with sub-metering in Connecticut from a legal point of view, but
I see.
Our situation is actually the opposite. We have smaller multifamily buildings, and so therefore tenants pay all the utilities themselves, and so it's easier to justify it here in this situation. And when they all have either no AC or window units, so this potentially could replace that. What we found when we kind of did a study of trying to switch from baseboard heat, gas-fired baseboard heat, to standard, mini split heat pumps, the cost of heating was going to be higher to the tenant than switching from gas. So NYCHA, right, that's a steam system, not very efficient. I'm curious if you have any data comparing it to, gas-fired, boilers, with hydronic heat, not steam heat.
Yep. Very common question. And I think a common issue as well. We have heard that from many customers who say we looked at doing mini splits and this is going to increase the cost of heating. And as I mentioned previously, we designed this system to both be consistently operated in the field at our rated performance. We did our best to design out any sort of improper installation that could cause performance to be below nominal. And the fact that it's zonal control also increases performance because people tend to only turn it on in the rooms that they need. We have done some analysis for customers where they have hydronic baseboard heating, where we showed what we expected the cost to be after install. We do think that we should be cheaper to operate in many cases against electric baseboard. And so we'd love to chat and kind of model out what we think you would need in terms of gradients and how we think they would perform. And then lastly, for a lot of our customers who have questions like that they want to verify, we can set up pilot programs or verification programs where we pick a number of apartments, we install the gradient, we measure the performance remotely or with third-party measurement devices and show that the math we did is actually operating correctly. The advantage of the modular nature of our system and the easy install of our system is you don't have to go all in. You can try out the system in any number of apartments and we can verify that you're going to save the cost that we expect before you move forward with the whole project. And so we're happy to take a look at the project, give you our estimate, and work you through how we would verify that that estimate's correct before you complete the building.
Yeah, would love to be a pilot for this. I mean, our buildings are very, very typical throughout Connecticut, you know, so if you can justify this in one of these apartments, you know, it's replicable, you know, all over the state.
Great. We'd be happy to. We'd be excited to.
Okay, other questions?
Yeah, so Vincent, first of all, this is fantastic. I learned a lot. I think it sounds like Patrick is pretty familiar with this, but you might want to, run through, show some of your earlier slides just so he can see them. But we've had a lot of talk about cost, but I didn't hear you say what is the cost of the unit.
Mm-hmm. So we tend to quote full buildings or full projects. We don't have a list price, and that's because we work with customers to figure out exactly how many systems they need, how they want to install it, and if they want a third party to install or if they want to do it themselves. And we've had both. We've had customers who say, just come train our building staff and they'll do the install. We've had customers who say, we want a third party who's trained to come and install it. So we end up quoting full projects. And so I can't give you a single number for a list price. But I can tell you that after everything, it is almost always less than $4,000 per gradient fully installed. We find that on a per room or per BTU equivalence basis, P-tax and mini splits are almost always between $5,000 and $9,000. And so that's why I say we're about 50% of the CapEx. Usually when we give someone that quote, it's less than 4,000 and they're getting other quotes that are, often between 6,000 and 8,000 per, again, depending on how you want to do it, per room, per 400 square feet, whatever the basis is.
I wish those were the numbers we're getting.
What are you seeing?
We're seeing much higher costs.
Oh, really?
Yeah. So,
Okay.
yeah.
Great. We can save you even more money. We're happy to hear that.
Yeah, that's good to know. And so just to kind of understand the sweet spot for this system, can you tell us a little bit more about that?
Yeah, I think it's really, let me see, I think I have a slide on this. I'm not sure. I don't know if I have a slide on this. The sweet spot's really pre-1980s multifamily. It is buildings that have either a boiler with steam heat or with hydronic heat, or electric baseboard heating, and either no AC or window AC. We do some newer multifamily buildings that are newer than 1980. We do some replacements of other types of systems, but really, if you have no inbuilt cooling, you have a centralized fossil fuel heating or electric resistance heating, and you look at your window and it looks like this window, there's a pretty good chance that we're going to be a great fit. But we'll pick up the phone for whatever type of project you have. I also mentioned earlier, we are in the not too distant future going to start focusing on single family homes as well. And so if you have a project that you want to talk about, we'll talk. It might not be this year, but happy to chat. And if you have another situation where you've got this type of window and you think this would be a fit, let us know and we'll take a look at your project and see what we can do.
Yeah. It's not the work I do now, but I used to do a lot of work with manufactured home communities, and it seems like it might be a solution there.
We just had a conversation with actually not this market, but an adjacent market, trailers for construction. We've started to kind of understand this market, manufactured homes. So yes, if this is an area that you have interest, we would love to talk.
And so can you talk a little bit more about maintenance protocols and costs and what goes on with that?
Yes. The only scheduled maintenance is cleaning the air filter. That's what this gentleman is holding here. Like I mentioned, it is a very standard type of filter. It's the same filter you would see in a mini split or in a window AC. It is washable or replaceable or vacuumable, whatever you would like. There's also regularly scheduled maintenance to clean the condensate filter. There's a filter on the condensate pump. It is at the bottom right of the system. You can kind of see it here, although it's not really identifiable, but it is accessible by removing the front panel. You unscrew the filter, and then it's pretty straightforward to clean. And so anything that, you know, a regular user could do or a building maintenance staff could do fairly easily. And it's what you'd expect from any cold climate mini split. When something unplanned breaks, all of the replaceable components, electronics, sensors, etc., are generally accessible with a screwdriver and, you know, 20 minutes. And so what we often do is we monitor the systems remotely. If we see an error in the back end, we can often get ahead of it and fix the issue before the user sees an outage. We can also send folks who don't have HVAC training to repair it. Mini splits often need service because they've leaked refrigerant. And when you have a refrigerant leak to fix, you need an EPA 608 technician. They need to find the leak on site. They need to fix the leak and recharge refrigerant. And that is skilled labor, and it's an emergency visit, and it takes a long time. None of our repairs are like that. The fact that it's hermetically sealed means that we should dramatically reduce the likelihood of leaks. And in the worst case, let's say something does happen and the whole system is gone, you can swap out the system with a spare in about 15 minutes and be back up and running. The whole system comes off the bracket, you put a new system on the bracket, and you're good to go. And so in addition to having almost no scheduled maintenance beyond the air filter and condensate filter, we want maintenance to be as low cost and as fast and as predictable as possible.
I'll also add that we have a whole suite of videos that are really straightforward, very simple for users to watch, like 5 to 10 minutes, about how to do all of the things that Vince just mentioned. We also have a manual that people can read, but we know that people don't always want to read a 80-page maintenance manual, so hence the videos are a little bit more digestible.
Great.
And so when there are inevitable failures, nothing is, you know, nothing doesn't happen. Have you tracked, you know, that rate? And I know, you know, it's a relatively recent product, but do you have an idea of an expected lifetime?
Oh, we have most certainly tracked that rate. This is a very important number to us internally. And we, you know, we've seen initial errors that are, you know, what we'd expect or better than for any new product, any new piece of hardware introduction. And so we're really happy with the field performance that we've seen so far. I also say that, you know, the other reason we want this to be monitored from the cloud, again, this is not something our customers have to worry about, but the faster we learn what's going wrong, the faster we iterate on the product. I think my sort of technologist opinion of the HVAC industry is part of the reason hardware is so slow to change, is because the line of communication from somebody frustrated with their HVAC system in their home to the designer of that HVAC all the way, you know, past the installer, past the distributor to the manufacturer, like that line of communication almost doesn't exist, right? We want to know immediately what's failing in the field and why, so that we can fix it in hardware as fast as possible. And so we have really fast design and iteration cycles because we know exactly what's going on with our fleet. And so we are a new company. We've made sure to set up a program where we can make sure that our systems have high uptime, that any issues that customers see are fixed immediately. And long term, we want to be able to show that this system is a much more reliable platform than competing products. Last thing I'll say is all of the internal components are standard cold climate mini split components. There's no new widget that hasn't been in the field for a long time inside of this. We use off-the-shelf reversing valves, expansion valves, compressors, copper tubes, etc. And all of those systems are designed and rated for a 10 to 15-year life. The most common cause of a failure of a compressor is when refrigerant leaks, and because of that, it loses lubrication or overheats. We've designed out the refrigerant leaks. And so we're really trying to use understood products that have demonstrated long lifetimes and put them in an application where they're being used as intended, being monitored continuously, and never going to operate out of spec, so that they continue running for a long time.
Great. And I know we're at the end of the time, so I won't ask more question, but it seems to me this is a great, could be a great emergency repair project. What's your capacity to deliver, in a short period of time in that case?
That's a great point. We have been keeping an eye on that because we do hear this often from customers when there's an emergency and heat is down and they need a solution tomorrow. We have the ability to walk in with a system and have it up and running quickly. Today, if you called us today and said, how quickly can you get me 5 systems? I think we would say tomorrow. If you said, how quickly can you get me, 100 to 600 systems, we would say a couple months. And if you say, how quickly can you get me more than that, we would say, 6 months or something. You'll talk to the sales team and they'll give you the real answer. That's my estimate. And so we don't have a ton of emergency capacity today, but we are working on it as we go over time, having some ability to do that so that we can handle any emergency calls. If your boiler goes down and you want, 300 systems and done in 2 weeks, theoretically we can do that. We've installed systems as fast as like 30 per day. And so, anyway, call us and we'll quote you lead times.
Great, thank you.
Okay. Yeah, thanks, Vincent, and Sam. It's been a really great presentation. Just following on quickly on what Kathy was talking about in terms of maintenance and stuff. What's the warranty on the systems? Your current warranty?
Standard warranty is 1 year, parts and labor,
Mhm.
5 additional years, parts. We can work, if you need a different warranty, we can work with you. We can figure out how to price it in, but that is standard.
Gotcha. Okay. And then I want to just note that Bryce has indicated that Eversource might look at providing an incentive for something like this within the chat. So that's great. And I think Sam answered that you're working with them in Massachusetts also. So yeah, it's terrific. I mean, I think that I think it clarified this for all the people on the call. Like I said, we will put this up on the Connecticut Green Bank archive list
Great.
and let you know when that's done and out there. And we will let all the people in the network know that it's up, which should be sometime next week, right, Vicky? I think it's usually, we send it to Rudy and get it probably by the end of next week.
Oh, definitely, yeah. It will be.
Yeah, and so with that, really terrific. Thank you guys for coming. Thanks to everybody who participated. Any final questions or comments from anybody before we close?
No, thank you. This was really great for me.
Yeah, that's great for me too.
I guess I would just I just wanted to end on, if you obviously I'll follow up with you, Bryce, about the Eversource integration. If you guys have programs that you'd recommend that we reach out to, please do reach out to Vince or I, and we will coordinate with them. I'm actively working with a lot of different utilities to spec out, what the performance is, what the predicted energy savings is, so that they can, create a prescriptive or a custom incentive with this product category, and really so that we can start serving more customers across the Northeast, but also in other jurisdictions. So, yeah.
All right.
Yeah, Dean,
All right.
will you when you share the slides, is there contact information on them?
Absolutely.
Yeah, Vincent can, and this will
Yeah,
all be up.
Vincent, if you can share the slides with me, I can make them available.
Will do.
Thanks.
Oh, that's right, Patrick. You came in a little bit late. Yeah, we'll send it, and the whole presentation will be up on the Green Bank archive site,
Yeah.
probably in about a week.
Yeah,
Okay.
if you send the link to me, Vicky, I'll send it to Patrick.
Perfect.
Thanks.
All right, everybody, have good weekends. Enjoy the somewhat cooler weather. I think
Thank you.
the heat pump's not going back into heating mode quite yet, but it's a little bit better
yet.
than it used to be. So, all right, everybody, have a good
Bye
one.
all.
Thanks.
Thanks.
Thank you all.
Yeah.
Everyone.
Bye.
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 I've forgotten, do you have a bracket outside the window? Or is it all held in by the window?
The bracket is, it goes over the window. And so part of the bracket's outside, part of the bracket's inside. But it is not, you don't need to physically screw it into any of the surfaces. And so you install it all from the inside. So you don't need to be
Yeah.
outside of the building. You can do it entirely from inside of the apartment.
Like a window AC, but
Yep.
yeah,
Exactly.
but a little more systematic, I guess, than they typically are
Yes.
in New York.
Yes, it's fairly robust too. It's pretty strong, especially compared to a lot of the fairly flimsy window AC brackets. I think if you were to install it, you would see pretty quickly that it feels very, very secure and bomb-proof compared to a window AC bracket. So I
Yeah.
think the analogy to window ACs is helpful in some respects, but it also like gives an impression of like very low quality commodity product, and that is not what this is at all. It is very securely mounted, professional, and meant to stay there for 10 plus years.
Yeah, great. And are you just, I mean, we can ask this question again, but are you doing anything in the single family market? Is it all multifamily? Does it make sense only on?
We have done some single family, and we will go back to it. Today we are all multifamily.
All multi, okay.
So, and you know, this audience is great for us. We don't know when we're gonna reopen single family, but it'll happen not too long from now.
Okay.
Vincent, when you're asking about the single family though, in our little close network here, there's a lot of people who work on neighborhood rehab programs.
Mm,
So they're not the traditional single family,
I
but
see.
they are, you know, addressing a lot of units. And I mean, obviously, I haven't learned about this yet, so I won't comment on the applicability, but it seems to me that that might be an important
Mhm.
area in particular, because one of their issues in that kind of work is what you disturb.
Right. So our main reason for not focusing on single family or direct to consumer is the different structure we would need for sales, marketing, and support. And if it's
Yeah.
something like you described, Kathleen, where it's a large group of single family homes that are coordinated by one entity, we're certainly in a better position to sell and support that way. So with most things in sales, volume fixes a lot of problems. And so we're certainly willing to speak with anyone and see what we can do for them.